Facial expression. A facial expression is one or more motions or positions of the muscles beneath the skin of the face. According to one set of controversial theories, these movements convey the emotional state of an individual to observers. Facial expressions are a form of nonverbal communication. They are a primary means of conveying social information between humans, but they also occur in most other mammals and some other animal species. For a discussion of the controversies on these claims, see Fridlund and Russell and Fernandez Dols. Humans can adopt a facial expression voluntarily or involuntarily, and the neural mechanisms responsible for controlling the expression differ in each case. Voluntary facial expressions are often socially conditioned and follow a cortical route in the brain. Conversely, involuntary facial expressions are believed to be innate and follow a subcortical route in the brain. Facial recognition is often an emotional experience for the brain, and the amygdala is highly involved in the recognition process. The eyes are often viewed as important features of facial expressions. Aspects such as blinking rate can possibly be used to indicate whether a person is nervous or whether he or she is lying. Also, eye contact is considered an important aspect of interpersonal communication. However, there are cultural differences regarding the social propriety of maintaining eye contact or not. Beyond the accessory nature of facial expressions in spoken communication between people, they play a significant role in communication with sign language. Many phrases in sign language include facial expressions in the display. There is controversy surrounding the question of whether facial expressions are worldwide and universal displays among humans. Supporters of the universality hypothesis claim that many facial expressions are innate and have roots in evolutionary ancestors. Opponents of this view question the accuracy of the studies used to test this claim and instead believe that facial expressions are conditioned and that people view and understand facial expressions in large part from the social situations around them. Moreover, facial expressions have a strong connection with personal psychology. Some psychologists have the ability to discern hidden meaning from person's facial expression. One experiment investigated the influence of gaze direction and facial expression on face memory. Participants were shown a set of unfamiliar faces with either happy or angry facial expressions, which were either gazing straight ahead or had their gaze averted to one side. Memory for faces that were initially shown with angry expressions was found to be poorer when these faces had averted as opposed to direct gaze, whereas memory for individuals shown with happy faces was unaffected by gaze direction. It is suggested that memory for another individual's face partly depends on an evaluation of the behavioral intention of that individual. Creation. Facial muscles. Facial expressions are vital to social communication between humans. They are caused by the movement of muscles that connect to the skin and fascia in the face. These muscles move the skin, creating lines and folds and causing the movement of facial features, such as the mouth and eyebrows. These muscles develop from the second pharyngeal arch in the embryo. The temporalis, masseter, and internal and external pterygoid muscles, which are mainly used for chewing, have a minor effect on expression as well. These muscles develop from the first pharyngeal arch. Neuronal pathways. There are two brain pathways associated with facial expression. The first is voluntary expression. Voluntary expression travels from the primary motor cortex through the pyramidal tract, specifically the corticobulbar projections. The cortex is associated with display rules and emotion, which are social precepts that influence and modify expressions. Cortically related expressions are made consciously. The second type of expression is emotional. These expressions originate from the extrapyramidal motor system, which involves subcortical nuclei. For this reason, genuine emotions are not associated with the cortex and are often displayed unconsciously. This is demonstrated in infants before the age of 2. They display distress, disgust, interest, anger, contempt, surprise, and fear. Infants' displays of these emotions indicate that they are not cortically related. Similarly, blind children also display emotions, proving that they are subconscious rather than learned. Other subcortical facial expressions include the knit brow during concentration, raised eyebrows when listening attentively, and short punctuation expressions to add emphasis during speech. People can be unaware that they are producing these expressions. Neural mechanisms in face perception. The amygdala plays an important role in facial recognition. Functional imaging studies have found that when shown pictures of faces, there is a large increase in the activity of the amygdala. The amygdala receives visual information from the thalamus via the subcortical pathways. The amygdala may also have a significant role in the recognition of fear and negative emotions. It is believed that the emotion discussed is recognized through activation of the insula and basal ganglia. The recognition of emotion may also utilize the occipitotemporal neocortex, orbitofrontal cortex and right frontoparietal cortices. Gender and facial cues. More than anything though, what shapes a child's cognitive ability to detect facial expression is being exposed to it from the time of birth. The more an infant is exposed to different faces and expressions, the more able they are to recognize these emotions and then mimic them for themselves. Infants are exposed to an array of emotional expressions from birth, and evidence indicates that they imitate some facial expressions and gestures, for example, tongue protrusion, as early as the first few days of life. In addition, gender affects the tendency to express, perceive, remember, and forget specific emotions. For instance, angry male faces and happy female faces are more recognizable, compared to happy male faces and angry female faces. Research has shown participants were able to recognize the facial expression of fear significantly better on a male face than on a female face. Females also recognized fear generally better than males. Communication. Eye contact. A person's face, especially their eyes, creates the most obvious and immediate cues that lead to the formation of impressions. This article discusses eyes and facial expressions and the effect they have on interpersonal communication. A person's eyes reveal much about how they are feeling, or what they are thinking. Blink rate can reveal how nervous or at ease a person may be. Research by Boston College professor Joe Techie suggests that stress levels are revealed by blink rates. He supports his data with statistics on the relation between the blink rates of presidential candidates and their success in their races. Techie claims that the faster blinker in the presidential debates has lost every election since 1980. Though Techie's data is interesting, it is important to recognize that nonverbal communication is multi-channeled, and focusing on only one aspect is reckless. Nervousness can also be measured by examining each candidate's perspiration, eye contact and stiffness. Within their first year, infants learn rapidly that the looking behaviors of others conveys significant information. Infants prefer to look at faces that engage them and mutual gaze, and that, from an early age, healthy babies show enhanced neural processing of direct gaze. Eye contact is another major aspect of facial communication. Some have hypothesized that this is due to infancy, as humans are one of the few mammals who maintain regular eye contact with their mother while nursing. Eye contact serves a variety of purposes. It regulates conversations, shows interest or involvement, and establishes a connection with others. But different cultures have different rules for eye contact. Certain Asian cultures can perceive direct eye contact as a way to signal competitiveness, which in many situations may prove to be inappropriate. Others lower their eyes to signal respect, and similarly eye contact is avoided in Nigeria. However, in Western cultures this could be misinterpreted as lacking self-confidence. Even beyond the idea of eye contact, eyes communicate more data than a person even consciously expresses. Pupil dilation is a significant cue to a level of excitement, pleasure, or attraction. Dilated pupils indicate greater affection or attraction, while constricted pupils send a colder signal. Sign languages. Facial expression is used in sign languages to convey specific meanings. In American Sign Language, ASL, for instance, raised eyebrows combined with a slightly forward head tilt indicate that what is being signed is a yes/no question. Lowered eyebrows are used for WH-word questions. Facial expression is also used in sign languages to show adverbs and adjectives such as distance or size. An open mouth, squinted eyes, and tilted back head indicate something far, while the mouth pulled to one side and the cheek held toward the shoulder indicates something close, and puffed cheeks mean very large. It can also show the manner in which something is done, such as carelessly or routinely. Some of these expressions, also called non-manual signs, are used similarly in different sign languages, while others are different from one language to another. For example, the expression used for carelessly in ASL means boring or unpleasant in British Sign Language. Universality Hypothesis. The universality hypothesis is the assumption that certain facial expressions and face-related acts/events are signals of specific emotions: happiness with laughter and smiling, sadness with tears, anger with a clenched jaw, fear with a grimace, or gurn, surprise with raised eyebrows and wide eyes along with a slight retraction of the ears, and disgust with a wrinkled nose and squinted eyes, emotions which frequently lack the social component of those like shame, pride, jealousy, envy, deference, etc., and are recognized by people regardless of culture, language, or time. The belief in the evolutionary basis of these kinds of facial expressions can be traced back to Darwin's The Expression of the Emotions in Man and Animals. Reviews of the universality hypothesis have been both supportive and critical. Work in 2013 by Nelson and Russell and Jack et al. Has been especially critical. Support. Ekman's work on facial expressions had its starting point in the work of psychologist Sylvan Tompkins. Ekman showed that facial expressions of emotion are not culturally determined, but universal across human cultures. To demonstrate his universality hypothesis, Ekman ran a test on a group of the South Ford people of New Guinea, a pre-industrial culture that was isolated from the West. The experiment participants were told brief stories about emotional events: happiness, sadness, anger, fear, surprise, and disgust. After each story, they were asked to select the matching facial expression from an array of 3 faces. The 4 selected the correct face on 64 to 90% of trials but had difficulty distinguishing the fear face from the surprise face. Children selected from an array of only 2 faces, and their results were similar to the adults. Subsequent cross-cultural studies found similar results. The Pioneer FM Facial Action Coding System 3.0, FM Fax 3.0, was created in 2018 by Dr. Freitas Magalhães, and presents 4,000 segments in 4K, using 3D technology and automatic and real-time face recognition, Face Reader 7.1. The FM Fax 3.0 features 8 pioneering action units, AUs, and 22 pioneering tongue movements, TMs, in addition to functional and structural nomenclature. Since 2003, FM Group International, FMGI, has had a fax certification program for professionals who wish to become fax, FM Group International Fax Certified Coders, FGIFT. Criticism. Both sides of this debate agree that the face expresses emotion. The controversy surrounds the uncertainty about what specific emotional information is read from a facial expression. Opponents of the universality hypothesis believe that more general information is pieced together with other contextual information in order to determine how a person feels. One argument against the evidence presented in support of the universality hypothesis is that the method typically used to demonstrate universality inflates recognition scores. Although each factor may contribute only a small amount to the inflation, combined, they can produce exaggerated scores. The 3 main factors are the following. Evolutionary significance of universality. Darwin argued that the expression of emotions has evolved in humans from animal ancestors, who would have used similar methods of expression. Darwin believed that expressions were unlearned and innate in human nature and were therefore evolutionarily significant for survival. He compiled supporting evidence from his research on different cultures, on infants, and in other animal species. Ekman found that people from different cultures recognized certain facial expressions despite vast cultural differences, and his findings tended to confirm Darwin's initial hypothesis. Cross-cultural studies had shown that there are similarities in the way emotions are expressed across diverse cultures, but studies have even shown that there are similarities between species in how emotions are expressed. Research has shown that chimpanzees are able to communicate many of the same facial expressions as humans through the complex movements of the facial muscles. In fact, the facial cues were so similar that Ekman's facial action coding system could be applied to the chimps in evaluating their expressions. Of course, differences between the species' physical facial properties, such as white sclera and averted lips in chimps, would mean that some expressions could not be compared. Similarly, Darwin observed that infants' method of expression for certain emotions was instinctive, as they were able to display emotional expressions they had not themselves yet witnessed. Facial morphology impacts expression recognition in important ways, and therefore, infant facial morphology may also serve some specific communicative function. These similarities in morphology and movement are important for the correct interpretation of an emotion. Darwin was particularly interested in the functions of facial expression as evolutionarily important for survival. He looked at the functions of facial expression in terms of the utility of expression in the life of the animal and in terms of specific expressions within species. Darwin deduced that some animals communicated feelings of different emotional states with specific facial expressions. He further concluded that this communication was important for the survival of animals in group-dwelling species. The skill to effectively communicate or interpret another animal's feelings and behaviors would be a principal trait in naturally fit species. However, this suggests that solitary species such as orangutans would not exhibit such expressions. Species such as orangutans would not exhibit such expressions. Species such as orangutans